Okay, so this is the particle video, another particle video, particle system. I'm gonna walk you through how we achieved this. Look, this effect, which is kind of a bunch of particles flying around the core and then slowly disappearing. And then we can also add some fancy stuff to it, some nice extra elements. Yeah. And then I'm gonna show how to make these reflections and the faces. So because these elements are twisting here, see this one that blinks. This is when the face of the particle hits an angle that it's reflecting the other elements, and then if you stick a glow to that, it will blink. So that's how you get this funky look. And you can also have it black and white. It also looks nice. Well, let's see. Yeah, see how cool it is. All right. So let's have a look at this setup and see if we can add some extra things to it. And then I'm gonna give you a couple of tips on how to prepare this and have it render at once. Okay, so what I have here is, well, at first, as always, I have a camera. That's the camera that I just find a position like this. You can create a camera. Boom. So you have a camera here, and then you switch the input, and that will go to all your cameras. So that's why I use the stamps, and I think everyone should learn how to use it. It keeps the script clean and super easy to change things. If you change the camera here, it will change all of them at once, so keep that in mind. So what I have is a particle emitter with a bunch of cubes. Every cube has a little material applied to it, and from the particle emitter, as you know, if you pull from the side, you can stick another particle here. You can keep doing this, so it will randomize the particles. It will randomize the elements. So what I have here from the particle emitter is just you know, a very high emission rate on frame 1001, and then it goes down 1006, 0, so which means it will emit a lot of particles here. They're all the cubes are overlapping inside of each other, and then from this point it stops emitting, but the lifetime of the particle is 200 frames with a range of 1. So this would add variation to the lifetime of the particle. But as you can see, they're slowly growing in size, and then 9. So how did I achieve this thing? So the velocity is very low. There's some variation in the velocity as well. You guys can copy the parameters here. There is some rotation, very low, and also some variation of rotation. So they're all rotating. If I kill the velocity, as soon as I touch, it changes what happens. If I kill the rotation variation, then it will be just growing like this. It can be nice if that's what you are looking for, but in this case I want them to be randomly rotating. There are a lot of cubes inside. The size also same thing, but then the size I have a bigger variation, so the range is it's much bigger. So you have tiny cubes and much bigger ones. You can see this little guy here. super small, and then we have some giant little cubes here, and then mass and range. This will only be useful if you use things that affect that in the particle system. And because I was doing this, I didn't know what I would eventually use. I always have one as a mass and some variation, transfer velocity, and 0.5 of spread. The spread is what makes them go out of the center or not. So the only force, because the spread is now zero, that's affecting them is the tiny velocity with some variation and some rotation. So they are spinning and they are moving away from the core, with some variation. So if you put back the spread, it means that it will spread from the center in all directions. Right? Pretty cool and pretty simple so far. So I always recommend to build the system in steps. So you need to train your brain on how to think like the particle system, so you don't you can prepare this kind of stuff and you know what you will do next, and then you can come back and change only what you need. So it's kind of a practice situation. So I have here some vortex animation from frame to 1012. So I gave them a little bit of time, so they are born, as you guys can see. They rotate a little bit. From this point, it's exactly like here. See, there's no change. All right, because it's all zero. From frame to 12, I add some, the motion starts, and then you can see the numbers changing here. I change it very quickly to the value that I found to be working best. So boom, it makes this crazy explosion. And as you guys can see, it's just a couple of keyframes to emit the particles from 0 emission, no, from 100 to stop emitting, and then so it's 100 per frame. So at this point I'll have 500. Boom. And then I have a quick animation here to make them go super far, like really exploding. See, there's some little guys very far from the center. There's one little guy there super far. So boom, go far, and then what I'm adding here is a tangential movement in the radial one. Radial is slightly weaker than the tangential one, so they explode in the same direction. See, this guy, he's going this way. See, so it's kind of a linear movement, and then you feel that the core is rotating, but the guys who are far, they are not following the radial rotation anymore. All right, so let me play this back again. Right, cool one. The rotation, the radial vortex will attract the particles back to the core, and that's why they boom, go out, and then slowly they will go back. And then if they come super fast, they will do like a planet, like we do around the sun. We come, and then there's like kind of a force, and then we go near the center, and that will add some propulsion, some extra propulsion, and boom, they go out again. So very simple and super cool stuff. All right, Great. So this needs some experimentation. You need to change the values and then you find what you like or not. See if I change, it reacts immediately, and this will make it spin like mega fast. Let's see how it looks actually. And then I can just delete. See how spins like crazy. Yeah, if this is what you are looking for, this is also nice. All right, well, this can be very fun. Then I use a very useful particle curve, and this I use to control the scale, the size of the particles themselves. So as you can see, they will not be born at 0, you know, like here a bit bigger than half their maximum size. Then they will reach the maximum size, because this is from 0 to maximum size. It doesn't mean 1, it means the, oh whoops, completely crashed. Okay, this happens. Let me open again. All good. Should be quick. Yeah, it's particle work. It happens. All right. Okay. Yes. Right. All right. Okay. Okay. So let's go back to this. So this will actually respect the scale you input here on the emitter and take into consideration the size range. So 0 means 0 scale and maximum scale. So my plan is to have them come a little bit, half the maximum scale, a little bit bigger, and then it will achieve maximum size. As you can see, the cubes are bigger, and then eventually they will die, because this is life. So they will reach their 0 scale as soon as they die. As soon as their max life, they will reach 0 scale, so they will disappear. So see, that's why I have some tiny little guys here that will eventually, boom, disappear. So that's the effect of the particle curve. It's pretty cool. Right. Nice. And then I just convert it to particle geo. This is a very useful node. You can freeze a frame if you want. If you want to a specific frame, see, it freezes the frame for you. It's pretty useful node. I always do this. I feel it makes the whole system a bit more stable, and also because now I want to transform the particles. So this is one of the systems. So I will rotate one like this, one like this, one like this, one like this, and merge all of them together, and then you have a circle. So if I go back to 0, boom, but now it's spinning against the circle, and the whole explosion happens in the circle. See, it's pretty cool. This is a nice trick. I know you will have the same variation here. So once you have the layout, which is this, and you're happy with the layout, let's say okay, I'm happy with this, I like how it looks, you can obviously duplicate this guy and connect to the other one and make a slight change on the seed. I can even do it now. Let's do it. And then you want put it so to avoid to crash. So this is the particle, okay, let's change the seed. Right, so it's not exactly same, slightly different, right? So they are all not exactly the same. We can do this, that's fine. For the tutorial, It's just the concept of how to deal with this stuff and how to use this kind of tools. But obviously you can do this and change the seed. You can change the values a little bit if you want, that's fine. But in this case, if you want to keep a consistent scale, but just change how they look, see, you change the seed a little bit, it's all good. Then I have a light, which is in the very center of it, on 0, 0. And I have a camera as well, which is this view. And this is how they look. So as you can see, all my cubes, they have a foam, a material, and a constant color. So I will have slightly different shades of color depending on how they are facing the light, that it's in the center or not. You can play with the materials as well and find the one you like. I also have a separate render on the side here for the occlusion, which is always nice to have. You can add some contact between the pieces. And then I have the reflection guy. So for the reflection, what I did, I put a, oops, where is the cube? Here? Yeah. So I put a cube, quite a pretty big one, in the middle of the stuff, but only here. So I took the whole scene that we had before with the particles and the light. I apply a material in the whole scene, and then it will apply only the gel, of course, of reflection. Put a cube inside of the system with a very strong light color. So it will give me this kind of a reflection. We don't see it now, because here I am outputting the AOV with the name reflect. I'm removing it from the beauty pass. So if you come to the channels here, the shuffle, you see reflect. If you shuffle it to the RGB, that's what you get, which is when the face of the cube is facing inside, like facing inside the system, they will catch the light. And that's how it looks. Nice. So I have three renders here. I have the reflection render, which is this guy. I have the main render, which is basically just the color. Nice one. And I have the occlusion guy. Alright. To apply the occlusion, you can use the ambient occlusion node. Constant color, apply material to the whole scene, and then it will apply to all the things. And then the occlusion has some controller here on how far you want the occlusion to act. Let's calculate it. And how well you want it to produce the stuff. So if I put in 1, for example, it's less rough. See how it's only on where they really touch. And if you put the value lower, it will produce a more scattered. See how contrasted it gets. So in this case, I want it like this. I have only 5 samples because we don't, in this case, don't need more. You can have more if you want. And also you can increase the samples on the ray render itself. So now it's at 5. If you put 10, it will give me a cleaner occlusion. So that's how it works, right? So what I do for the occlusion is to invert them, because I want to use them to act on the particles. So instead of getting occlusion like this, I will get occlusion like this, which is inverted. You can render it with better quality if you want, obviously. And what I'm doing here is to, because this is in the RGB, to move this to the alpha, I really like to use the max operation in the expression node. How does it work? You max. So it will max them values instead of adding or plusing, to max the values of RGB. And then after this, you can add whatever operation you want. So in this case, the value I found to work better was 2. So if you go to the alpha, RGB alpha. If I put 1, it's not so strong, you know how it is. So that's how I like. In this case, it's RGB, it's black and white, so I don't even need to have all of this. If I do this, it's possibly the same result. Yeah. So, but anyways, this is I do that so much that this is automatic. So it's max, open close bracket, RGB. When you do R plus G plus B, you get this, and if you in the max operation, you don't add them, you don't add plus to the value. You just do it like this, and then see if you hit enter, and then it shows you the result. But because the syntax is different for R plus G plus B, you need to add a plus. If you max, you just point to which channels you want to be maxed with a comma. So G, B, and then it was not strong enough, and then we can multiply it by 2, so it multiplies your result. Pretty handy stuff. So then I just use it to grade down a little bit, and gamma down a little bit, gain and gamma, so it adds more of the, makes it less flat, right? You can feel a bit more of the sides are not exactly the same shade, so it's nice. And here we have the reflect guy, which is rendered, and I use my favorite expression again, but this time I don't multiply anything, I just max it all the values to alpha and use it to make it slightly brighter. So as you can see, it has it's a reflection, so it's reflecting the cube inside that was here inside. That's why we get only on some edges, on some, you know, some corners, the bright stuff, right? So that drives the glow. I really like this one. It's called Fibonacci glow. You can find it on Nukepedia. I really like this one. You can have it on top of your result, or give you just the effect, and then you can tweak it. And I like to plus it like this. Pretty cool. I add some motion blur. And motion blur, it's coming from the main render. This guy rendered it with all the passes, this one. Alright, it's taking the motion blur, great. And then I render it out, that's the result. From this result, I make like a giant blob and just plus it on top to add some variation color and not have only the green stuff on top. And here you can play around with the saturation if you want. So let's see the result, how it is. Yeah, see, very simple exercise. This is the kind of stuff that will give you the confidence you need to approach a shot with particles. You will never find a tutorial for exactly what you need, you know, apart from rain or snow or something like that. But to be able to build things quickly and be comfortable with the tool, I 100% recommend doing this kind of exercise. You know, when you build something that looks like a Nucleos with stuff flying around a center, to be able to tweak the forces on the vortex so the particles don't fly away forever. This takes a bit of time to tweak around. And yeah, so this is the particle tutorial I promised to do before I publish the copycat video. Copycat video takes a while, but I was lucky to get a couple of very cool footage to test with a guy walking in a hangar, and so the copycat video will be super cool, but it will take more time, so that's why I'm making this in the meantime. And that's also something I like to do in my free time, to play around with particle systems. And the last tip that I have is how, if you build a system like this, you need to be able to tweak it quickly. You know, if the supervisor says, I like it, but can I have the particles instead of these colors here? Can I have one that is like purple? I would say, yeah, sure. So what did I do to be able to do this quickly? I use the no op guy. You can find 1000 tutorials online about this, and I linked very simple to all the switches I have. So the switches are pointing to the render at this point, at this moment. And if I take this little guy and switch it all to 0, it will force to calculate. And you see it will change how it looks, because we did this change. Remember, we duplicated and changed the seed of one of the guys. See, so there's a difference there. So yeah, see, nice. And then we can live. I think we can even skip the motion blur. I'm gonna do another trick that I hope you guys all know. If you go to the disable and stick this there, which is a $sign plus key, which is the user interface, it will make the node invisible when you are with Nuke open, but it will render it. So yeah, the motion blur is there, but you don't have to calculate it all the time. So now the tree is live, and then you can come here and say, okay, so they want it purple, right? All right, so you can add a new one here. Add this little guy here, another variation, nice one. Let's make it purple. That's it. This will change all of them, yeah, because it added a new stuff with variation. Maybe the purple is a bit too strong. Let's tweak it a little bit. Maybe this little guy. That's it. Yeah. All right. Cool one. And then, all right, let's say you're happy. So I would like to render all of this at once. Nice. So go back to the little no op guy. Switch all the switches back to the render, right? And then you go to all your right nodes and number them. So this is number 1. This little guy here, number 2, right? Number 3. Okay, number 4. Great. So this will overwrite what you used to have before. But maybe that's what you want. If you don't want to overwrite, you can add a version here. This is version 1. You can stick a new version here. Do that on all the renders. Great. And then once you have it all set with numbers and all the switches pointing to the render, you want to send all of them at once. You come to render all right nodes. So that will go rendering 1, 2, 3, 4. As soon as it renders 1, it will overwrite. It will render 2, overwrite, 3, overwrite. And when it reaches this one here, the last one, 4, it will be actually reading the new render, not the old one. So in my case, I'm gonna use the frame server, and done, it's rendering. So that's it. And I hope you guys enjoyed this one. I hope you guys learned something useful. I will be working on the weekend. I'll find time to work more on the copycat video, and I hope to be able to publish the copycat video Sunday evening. And yeah, all right, thank you very much, and I hope to see you soon. Bye bye.